Hey everyone, I'm super excited to be here with you at Sonoma Hacks. My name is Pronnoy. I'm a software engineer at Workday, and in the past I've worked at Microsoft, McKinsey, and PayPal. Today we are going to explore how projects you build at hackathons can actually scale to billions of users in the real world. This talk is titled From Hack to Scale: How Real World Systems Are Built and Why You and Your Code Matters. So let's dive in. A bit about me. I am a software engineer at Workday. Previously at Microsoft, I've worked at PayPal and McKinsey and Company. I did my education in from Virginia Tech. I did my master's in computer engineering. I am an avid writer. I have a LinkedIn newsletter called Distributed Bytes with Prannoy. I often mentor, judge, and serve as technical reviewer at top conferences around the world. My expertise lie in distributed systems, AI, cloud infrastructure, AI, ML, and observability. My goal today is to share what I have learned from building systems in the real world so you can build better projects even at the hackathon level. So let's move forward. Why this talk? Hackathons are incredible launchpads. Some of the most exciting products started as weekend hacks. But in reality, many hacks break when they start getting attention or customer traffic. But why? Because the real world demands more than just working code. It demands systems that are resilient, scalable, and observable. Today, we'll break down what that actually means and how you can start applying these ideas into your weekend projects and hacks. So let's move forward. The three pillars of scalable system. So think of any large system like YouTube, Discord, or ChatGPT. They all need three things: resiliency, scalability, and observability. Resiliency is about recovery. Your system will fail, and systems are bound to fail, but it needs to bounce back. That's what a good resilient system does. Scalability means that it should grow with traffic. A project that works with 10 users should still function as intended for 10,000 users. And observability is about being able to see what's going on because you can't fix what you can't see. So let's take a look into what happens when things actually scale. So this is a very funny thing that I think you will face as you move forward in your software engineering career. I'm not sure why this is failing. It works on my machine. And then you'll realize from other like architects or people who have had experience that the same code that works for 10 users may completely fail for 10,000 users. So what happens? What breaks and why it matters? Essentially, when more users show up, things start breaking. Maybe your code is single threaded, or maybe your database can't handle that load. Suddenly, people start seeing errors or the app slows to a crawl. This slide shows you what typically breaks and why. The reality is, these issues don't show up until you start seeing growth. That's why thinking about scale at the early stages gives you an edge over your peers. Let's take a look into a real world example, which I think a lot of us might have seen or even used. Which is Instagram Live. You press one button, go live, but behind the scenes, the video is getting captured, transcoded, and distributed across the world. There's moderation, logging, auto scaling, all happening in milliseconds. This level of complexity that real systems deal with is actually what happens in real life. And yes, they use the same tools you can start learning now: queues, message queues, CDNs, and observability tools. Essentially, what you see here is a very bare bones uh, structure that flow that I've shown on how what happens when an Instagram live happens. Essentially, the influencer goes live. There are millions of servers behind it. There's a transcoder that transcodes this video format into different formats for all devices, and then there is this content distribution networks, which are like global content warehouses which serve specific regions, and then end users start watching this. So what you feel is just like a simple press of the button to hit go live. Behind the scenes there are so many things that Instagram has to handle. So let's move forward. Now let's think about what are the now we saw real world example, and now let's think about what are the actual building blocks that lay our foundation and knowledge to start building products like Instagram. So if you want to build things that scale, you need to start thinking in terms of systems. Stateless versus stateful services, retries, timeouts, load balancing. These are not just enterprise concerns. They apply even if you are just building a simple chatbot. Learn to decouple components using queues. Use logging and metrics to track behavior. These are habits you can start developing right now and start upskilling yourself. A great resource for this is System Design Interview book by Alex Wu. I'm not endorsing anybody, but I think that book is really good. And if you want to get into more details, there's another book called Designing Data Intensive Applications by Martin Klipman. That is also a great book, must read. And then there are a ton of YouTube videos and tutorials on various platforms which you can leverage to learn about these topics. So now today, like there's a lot of hype around AI. So we can also talk about how AI models work in production and what are the challenges. So AI sounds magical, but when you actually put models into production, you face a few set of problem. Face a new set of problems. Inference takes time, prompts can change output drastically, and you need to monitor for bias or failure. For example, if you build a skin disease detector, like somebody did last time in Sonoma Hacks and One, you need privacy protections and ongoing validation. AI in the real world is a system problem, not just a model problem. And also, it's a problem about being ethical and unbiased. So that is something that is more of a human problem, but there are system challenges also deploying AI models at scale, serving billions of customers. So, yeah, we need to think about those things as well. Responsible AI and ethical AI. So now moving forward, what does my day-to-day looks like? So I think we have seen a lot of videos on YouTube on day in the life, which popped up during the pandemic. But actually, the day in the life is not so funny, not so fun and happy than what is shown on social media. So as I said, like there are bunch of meetings where you have to be there, listen, and provide guidance and learn from your peers. I typically write a bunch of design documents for the features that we plan to implement in Workday and also in the past. Then I get focus time to build things which actually move the needle. Then I also get to review code of my peers. Like there's a process called code review, doing pull requests or change requests. So people review your code. Essentially, like I said, usually you require two approvals to move forward. So yeah, and I also perform of activities like mentoring others, being in meetings, debugging incidents, and collaborating with product and infra teams to design product roadmap and what we want to do for the next quarter. So what I've learned is that it's not just about coding. It's about communication, architecture, and building things that don't break under pressure. So that is a lot of things to digest. So now I think we are moving to the final stages of the presentation. So let's talk about what are the lessons learned. Like these are lessons learned or like my 2 cents, what I've learned over my experience of around 10 years working in tech and building things at startup level, at the level at which Microsoft operates, at the level like at mid-tier level where like there are millions of customers, not billions of customers. So yeah. So some quick advice from me to you: build fast but think long term. Hacking is great, but you should think long term. Ask yourself, if this project goes viral, will it survive? Am I ready? Think about those things. Learn the fundamentals of system design: queues, APIs, retries, load balancers, uh, load balancing algorithms, basic data structure. These are essential and is required at any job. And always prefer real world projects over tutorials. Yeah, I would say this definitely. If you want, like tutorials are great just to get started, but then you need to build something. If you build a tutorial, I think it's not very in depth. Most importantly, don't be afraid to break things. That's where the learning happens. Because things will break whether you want it or not. But you should be able to bounce back from that and learn from it and move on to the next challenge. So let's recap what we've spoken about in this talk. Scaling isn't about magic, it's about mindset. The best engineers don't just write code, they anticipate failure, monitor behavior, and evolve systems over time. Whether you are building for a school project or company systems thinking will make your work stronger and more resilient. And you'll also feel passionate about building new things when you learn about new systems, architectures, and distributed systems and technologies and new things that come up. And as I said previously, mistakes are bound to happen. Don't beat yourself up for it. Just learn from it, move on, and get to the next problem. So yeah, with that, I'll conclude. Thank you so much for the time. I hope you found this workshop helpful. Let's connect and keep building. You can connect with me on LinkedIn, follow my newsletter called Distributed Bytes with Pranay, and happy hacking. And remember, great systems always start small but scale with purpose. Thank you so much.